Hi, I'm Aaron. I write code. I do code things. Currently working as a contractor at Platformatic. Also, 2 times ex-Cloudflare intern, going back there this summer again as well. Also, Node.js contributor. I've touched a lot of things or not a lot, but a few things in Node Core, but mostly focused on the web infrastructure side of things.
Hey, is it working? Yeah, great. I'm Claudio. I'm a senior software engineer, a platform engineer at HubSpot. I'm also a core collaborator at the Node project, one of the recent maintainers of Webpack, and also a CPC member on the OpenJS Foundation. So we're going to talk today about how Node.js binaries are served at scale. Please do not try to translate it. Thank you.
That's what it translates to.
Yeah, actually, yeah.
So just for some numbers here, the Node.js.org domain gets about 2.4 billion requests a month. Just to the website as well, we have about 21.8 terabytes of traffic a month. As far as release assets go, so binaries, documentation, also some of the legacy metrics, it's about 2.2 terabytes total. And with those 2.2 terabytes, we're serving about 2.4 petabytes per month of those. And just the sort of general request breakdown, if you want to.
Yeah, the breakdown of the requests pretty much downloads, actually 500 million requests, just people downloading Node.js happens per month. So that's actually more than 1 billion downloads per year, Michael. Thank you. We also got a DDoS attack, which we didn't even notice because the infrastructure is so great that, just fly like an ease. But it was around 30 million requests. Interesting fact, nowadays from our total of 2.4 billion requests per month, 386 million requests people are using HTTP 2. Thank you for using modern web standards. Then 85 million requests go to indexer tab. NVM, hi. And for some reason, 1.4 billion requests are from people without any user agents, so the phantoms. And I really wonder who they are because there's no information about any of them. So I'm not sure if it's a Cloudflare issue, but it's very interesting anyways. And another fact, it didn't even fit here. 500,000 requests per month actually come from ChatGPT.com. So a bunch of people are asking, what is Node.js, I guess? And they're just hitting our website because, it sources from the internet. But that's, interesting fact. OpenAI, please pay us. Thank you.
So let's just go over sort of what our infrastructure currently looks like. This is sort of what the release process looks like for Node.js. So we have the release CI that has a bunch of builds that write to a single server. That's referred to as the origin dist www server. It's sort of interchangeable, but it uploads them through just SSH, and they stay there in the staging directory until a releaser comes and wants to promote the release. And they do so with the release script that's in the Node Core repository that copies the binaries from the staging directory to the dist directory, as well as uploads the signed SHA-SUM files. And that makes it publicly available for a client to come in and request it through, and that goes through Nginx on the server. That's also behind a Cloudflare cache.
Yeah, well, that infrastructure model has some issues, and unfortunately, those are not GitHub issues in the literal sense. Well, we have pretty much a single server that is managing all of the load. It's an Ubuntu server on DigitalOcean, which is manually deployed. There's no really actual backups beside of disk images that when you need to roll back to them, it creates unavailability. There's very little documentation regarding the infrastructure. There's a lot of magic behind the server, very little knowledge regarding certain things. There's no real testing environment behind it. And there's very high friction, when updating or adding dependencies or changing anything on the server because, if it breaks everything. And there's no way to go around it without, besides of, rolling back the disk images, which are also not always up to date. So, it's a single server. Although we added a lot of CPU and RAM, you still have limitations from the kernel, from the OS, and from how much, file sockets can be opened at a time, or, everything that you have a constraint of, an OS environment that is not an actual, server. Then you have, every time that we need to make any change to there, even if we make the changes on Git first, someone from the build team needs to actually deploy them and test them and ensure that nothing actually breaks and that they are there to verify those things after many hours. And, there's an inefficient caching model because promoting releases, and that's just for historical reasons, will purge the whole Cloudflare cache. It's a little bit difficult to pinpoint what exactly needs to be purged or not at that time, because many different scripts will actually try to do many different file changes. But this is something we're working on. And that kind of creates a domino effect because, new releases often trigger issues. Since cache purges, that just opens the floodgates for everyone making requests to the origin server, be it Cloudflare, be it you, be your grandmother, maybe, open chatgpt.com. And that causes kind of a DDoS effect, although it's just people trying to actually access the assets. The origin servers become so overwhelmed that it temporarily reduces its functionality. Not to mention spiking error rates, so people start getting internal server errors, people cannot download Node.js, and that's definitely not a great user experience. And this is also something that at times can happen for a long period of minutes. Sometimes it's very quick, and sometimes it creates major incidents like the one we had on March 17 on 2023, which was also one of the starting points where we realized we got to change this. This is not sustainable. Which goes to the next slide regarding incremental problem solving, which I can talk about it. We tried over time to solve things as much as we could. So for example, NGX, which is what is running on the server, there were a lot of configurations that were not optimized, like default settings. So how the compression works, what should be cached, hot paths, because you want to ensure that only the things that are actually being requested a lot are cached. The other things you can kind of disregard, optimizing certain resource constraints and etc. Clean up of the configuration, documentation of it, deduplication of a lot of the logic that was there. Then on the firewall side of things, actually there are a bunch of like Java package managers like Artifactory, JFrog, Grado that spam Node.js.org because they think that there's an npm mirror. So we get weird requests like, for example, someone trying to download Express.js from Node.js.org and just like, we get it, but we're not npmjs.com, wrong domain. Then we have bot and crawlers that also just try to, make very weird requests all the time. We also then, created those firewall rules to ensure that, we reduce the amount of spam that we get, reduces the overflow that gets in the server. Then we did cache optimizations on Cloudflare, cache purging rules, and what gets actually cached on NGX and not, and how the distribution between the main server and the backup one should go, and trying to document everything that we have as much as possible within limitations of historical knowledge. But of course, this is, even after all of those changes and fixes, this is unsustainable. The main reason because, well, we have a lot of issues communicating this to our users, like how can we reliably as an open source project tell to all our users, hey, we're right now facing this issue. Often what happens when Node.js.org is down or having issues, well, users will spam our repositories, different repositories with issues, hey, Node.js.org is down. And, well, we know it's down, but how you communicate it to the user. It's very difficult to show that the user to be aware because even if we pin a comment or pin an issue or comment somewhere, people will just not realize that, oh, this is a person from the Node project or someone already is working on this. And doing status page updates, well, not everyone has copywriting skills, and So making commentary that is succinct and very easy for people to follow. Plus, who here knows that we have a status page? That's great. Yeah, we do. Status.nodejs.org. But see, the issue. We have difficulty to actually do incident management. We're not a company, so how it's crisis management or incident response on an open source project. So we heavily rely on volunteer time to do things that should be paid, which is having an SLA, having DevOps engineering, and it is what it is. So were things that can be improved. We had to reflect a lot on that. And of course, reliability. We need stable servers. We need something that can be easily backupped, easily restored and distributed, scaled and etc. And to be as close as to 100% uptime as possible. Although we are an open source project and we do not have an SLA, it's not a real excuse that we can have because everything depends on that website being up. And maintainability, it needs to be easy to deploy, to change for newcomers and long-time contributors to quickly jump to the code and understand, okay, what is this? How can I understand? How can I make changes? To anything regarding how the assets get distributed or deployed or served. It needs to be something that is very easy for people to contribute. And they also should be confident that changing anything, you can break things. It's fine to break things because then you can just roll back them or just whatever. So you should not feel like bad about touching something and possibly breaking it. And it needs to be efficient, it needs to be very performatic, it needs to be fast in serving those, requests, and also, have very good caching and know what needs to be cached and what needs to be purged.
So let's work on trying to find a solution that can match what we need. And let's look at workers. You probably have heard of workers, if not from other things, but from also my dad's talk from yesterday. But it's just Cloudflare's JavaScript runtime. It's serverless. Then also R2. It's Cloudflare's blob storage provider. Think of it almost just like an S3 competitor. MinIO, SeaweedFS as well, sort of like that. Why don't we try out workers in R2 to see if it can help fix our problem? For starters, why would we want to try it? For starters, it's just a way to get us off of Node's infrastructure. To where we won't even really need to care about the infrastructure. Workers can infinitely scale, sort of, and so let's try that out. Node already used Cloudflare and has for a while as well, so if we can expand usage of Cloudflare, it would make sense. And why R2? Its pricing is pretty good. There's an asterisk next to that, and I'll get to that in a second. There's also the round trip cost. Again, it's Cloudflare infrastructure communicating with Cloudflare infrastructure. It's going to be pretty good latency-wise. Also, it's pretty reliable. I think the last time R2 was down was the incident that I caused like a year and a half ago. So, also, who here knows about Cloudflare's Project Alexandria? Okay, so it's Cloudflare's open source initiative. It was announced just last birthday week, so last September. And I'm mentioning this because it goes back to the pricing of we're not actually really paying for it because we're under that, which is super cool. And also this didn't really exist before September. And this solution that we're about to talk about is one of the inspirations for this project. So it's pretty cool. So what do we need the worker to do? For starters, we need it to be able to route the requests like it was in Nginx. We ideally want this to be sort of like a drop-in replacement. We don't want it to be really noticeable that things have changed. We don't want to break anything. So we need to handle even like the really simple routes. So /this/index.json, that's a really simple rewrite to where it exists in an R2 bucket or on the file server. Latest iron, that's a little, like the latest LTS branches, they're a little more complicated. On the server, they're symlinks. On R2, we don't have symlinks, so we had to get a little creative. It's just sort of an in-memory rewrite map that rewrites latest iron to whatever the latest Node v20 is. Then it gets a little bit more complicated, specifically with the node.js.org/docs directory, which is a directory that has both symlinks and actual directories in it. How do we, replicate that on R2 with the worker? That we're still kind of figuring out on that. Also, we need to be able to list directories. That's sort of self-explanatory. But also, we need to be able to emulate Nginx's directory listing response, because there's some Node CI that relies on Nginx's directory listing HTML, which was awesome figuring that out. Also, we need this to be performant again, so caching as well. We need to be able to cache the responses and rely on the cache working. Also, we need to be able to handle release promotions fairly well. Also, if we could come up with a better purging solution, so we're not purging the entire cache when a new release happens, which happens every night, by the way, with the nightly releases. So it's not great. Also, with the origin server, we need this to remain as a backup server. That's so we can use it as a fallback. Say there's some error that happens in the worker and it's unable to fulfill the request. Let's try just rewriting the request to the origin server, and it should be able to work. So this is sort of the request flow diagram that we sort of thought of with the worker. So we have a client that would just connect to Node.js.org. Cloudflare would route it. So if it goes to the website, it goes to Vercel. But if it's going to some of the release assets, it will hit the worker. That worker will see if the request is cached. If it's not, it will try to fetch the file from R2 or list a directory from R2. If there's at all some point of failure that happens within the worker, it falls back to the origin server. And this is sort of how it fits into the infrastructure diagram that I was talking about earlier with the release CI. So now the release CI, it still uploads everything to the origin server as normal. The release promotion doesn't really change at all for the server. Now, however, the release CI also uploads to Cloudflare. It uploads to a staging bucket, and the release script also copies the files from the staging bucket to the disk bucket, as well as the staging directory to the disk directory. And then clients connect to the release worker as well. So what now? We got here through 4 different implementations, and that means 4 different rewrites of the worker. The first one was really, really simple. We just checked if a file existed in R2. If it didn't, it rewrote the request to the origin server. There was no directory listing in the worker itself. We sort of just relied on the origin server to handle that for us. It is sort of just like the easy way out iteration. The second iteration, it was a fork of CotX's render library, which for those who don't know, it's pretty much, it lists files and directory listings of an R2 bucket as a worker. We made some small improvements to performance and maintainability that were specific to Node. Some of those also made it upstream. That also added we also added directory listing with this iteration to the worker. The third iteration, it was a complete rewrite from the previous one. It featured our own routing code. It was still a bit of a mess, and lots of hard-coded behavior was in it. So it was a little bit hard to change. The fourth iteration is where we're at currently. It was, again, a complete rewrite compared to the third iteration. It's a lot more modular. It's middleware-centric. We can swap out the order of operations on, so if we wanted to send a request to the origin server first, we can do that with a single line change. And it's pretty cool. Cover this one?
Yeah. Okay. Yeah. Oh, so what failed? So last NodeConf EU, when we were trying to test the first iteration of the worker, well, we broke also everything for 5 minutes. Lessons learned: do not put a worker behind a Cloudflare load balancing config. It doesn't like that. I think we broke the release script at least 5 to 7 times. The hard thing here is that there's no easy way right now to simulate a release process without actually doing an actual release process of Node. And since it's volunteer time and just a handful of people that have access, we need to closely work with them together, see the actual release process happening, take notes, see what failed, what not failed, and iterate on that. No easy way to do actual E2E testing here. Sorry, TDD lovers. We had to rewrite the worker multiple times, but that's a good thing. Because again, it goes to our goal that we want to have a thing that is easy to be maintainable, clean code-ish, and then any person can actually contribute to it and understand what is happening there. So we want to have good design choices to have it be performatic, in bug-free, of course. So it's kind of the philosophy of it will take some time to get there, but perfecting over time rather than rushing to release something, and then it's something that we are proud of. There were times that the origin server just refused to write files to R2 on initial iterations, and we had no idea why. It's interesting how certain CLI applications and command lines and things just work in different environments. Even things that you believe, oh yeah, it would just work exactly the same on this environment. Well, it won't. So that's another thing that failed. And how we future-proof it?
Yeah. So for starters, one of the main things was with the origin server is testing again. So with the worker, we have end-to-end testing and unit tests to make sure that we know exactly how the worker is supposed to act and perform. And so if those tests break, we can sort of diagnose it earlier and quicker before it affects any production traffic. Currently, we're using 3 dependencies as well in the worker in production. For starters, 80 router. For those who don't know, it's just a pretty small router that's meant for production or serverless environments, Cloudflare workers included. Also, Sentry as well for error reporting. They also kind of have to give Node a I think it was
open source grant.
Yeah, like an open source grant for our project for the website and the worker. Also the S3 client, because the AWS's or R2's bindings are kind of a little weird, and they have a size limitation that the S3 API doesn't have. And so using that for directory listings actually gives us some better performance. Deployment process as well. We have a staging environment as well as production environment. So the staging environment helps us diagnose problems earlier as well. So it just adds on to the testing. Documentation as well. We're really documenting it a lot. Kind of need to do a little bit more of it. That's the first actual architecture diagrams that I've made for the worker were the ones for this slide. Oh, yeah, and it also just decouples it from a single server, so it's more scalable.
A note, I want to add 2 notes in the previous slide. So one thing about Sentry is, for example, often when we have distribution issues, we were the last ones to usually know it because there's no observability and no instrumentation. By adding Sentry, as simple as it sounds, it gives us back the control on the first responders to understand something is not working. There's either outages or issues happening with the worker, or even to understand the performance metrics and be able to allow us to benchmark it and better improve the code in the future. And decoupling for our server is also very important. We want to, in the future, not need to depend on the origin server at all, and be able to, make the worker fully work just with the assets being uploaded directly from the CI when they generate the binaries. So what's next? We want to get it production ready. So there are still little things to iron out, like Aaron mentioned in the beginning. There are a few sort of symlinks that we want to handle, and we want to also make some abstraction there so that it's very easy for us to tell the worker what paths or namespaces need to be handled or rewritten or redirected. Then we want to flip the switch. Actually, fun fact, a lot of the things are already being served by the worker. So Node.js.org/API or the nightly releases or like the V8 canaries, they already are being served by the worker. Our goal is maybe by the end of the year to have everything being served by the worker. We want to have some quality of life improvements, as mentioned also before by Aaron, in the code base, clean up tests, and improve also all the testing that we have. Usually Sentry Insights, which is for the performance insights, and then have some performance improvements like using Cloudflare KV for some of the cache entries, and also some synthetic benchmarks on some of the hot paths so we can understand how to better improve performance if needed, as needed.
And yeah, so if there's any questions, I think we have like 2.
I don't think you're going to have
Okay.
time.
Okay.
I'm really sorry.
There you go.
It's been so great that today we've had so many really rich talks. We're just not getting time for questions for you. But you will be available over lunch, yeah? And people can come up and have a chat with you about this. Please do hit them up with your questions. And give it up for Aaron and Claudio.
Thank you.